Okay, guys, I'll tell you how to find the time complexities now. So we have written just now we have written a code, right? So let me write the code again. The addition of two numbers code, right? So this is right. So void add, right, and int ab. Uh, I'll just directly write print get if b and print ab, a plus b, right? Close the loop, right? Okay. So here you check what is the time complexity of this algorithm. Somebody asks you, right? So that's very simple, guys. You have to just look for the total frequency count, okay? And you say this statement executes one time, this executes one time, this executes one time, and totally this will take 3 units to execute this particular algorithm, right? So that is 3 is a constant, right? So it is taking constant time, whether it is 3 or 4, but it is taking constant time, right? So because of that reason, the time complexity of this algorithm is O of 1, okay? The constant time complexity, because this takes constant units to execute, right? So that is O of 1. Okay, let's take another example, right? So let us take a for loop. Okay, I'm just writing a for loop alone. All right. So for loop I equals to 0. That's how you write a for loop in C programming, right? I plus plus, and I'll be having something inside. All right, some statements. I don't know what those statements are. So let me write statements like that. Okay. So if somebody asks you how many times the for loop will execute, okay, you can say that first iteration I equal to 0 one time, okay, then I will increment I equal to 1, next 2 times I equal to 3, sorry 2, I equal to 2 third time, I equal to 3 fourth time, I equal to 4 5 times, and when I goes to 5, it will only check this condition. Okay, so 5 is lesser than 5, it is not true, so it will not execute the statements inside the for loop. So the but it will check the, it will go for the comparison, right? It will go for the comparison. So of course sixth time execution is there, so this executes 6 times. Okay, so if you have 5 here, it will execute 6 times. All right, this particular statements will be executed 6 times if you have 5 here, right? I mean 5 plus 1 times, right? 6 is 5 plus 1, right? So 5 plus 1 time, and instead of 5, if I have 10 there, this particular statement will be executed 11 times. I think we are getting the relationship. Okay, let me write the for loop again. For I equals to 0, I equals to n. So now I'll generalize this particular for loop. I am having n here. So how many times the for loop will execute? It will execute n plus 1 times. Okay, I hope you got why it is n plus 1. So it will execute n plus 1 times, right? And all the statements will inside the for loop will be executing n times. Okay, if I have n to be 7, then this statement alone will be executed 8 times, and all the statement inside the for loop will be executed only 7 times. You know why? Because the extra stay execution here is the comparison, the last comparison where the condition goes false, right? And that's how it works. Okay, so outer the loop will execute for n plus 1, and all the statement inside the loop will execute for n. Okay, and this will work only if you have if you are starting from 0. Okay, if you are starting from 0, this will definitely work. What if I do like this? Can I do like this? I'll start from 2, then I couldn't say that this will execute n plus 1 times, because I'm just starting from 2, right? So what should I do in this case? Okay, so in this case you just have to do uh, you have to use a formula. I'll tell you a formula, a good formula. Please remember this. The formula here is upper index minus lower index plus 2. That is the formula to find the total frequency count of a for loop. This will work only for loop, guys. Upper index minus lower index plus 2, right? I'll tell you, the upper index is n here, right? So upper index is n minus lower index is 2. Lower index is 2 plus 2. All right. 2 will get cancelled and you'll get n. So this for loop will execute n times. And all the statements inside the for loop will go for n minus 1 time. Why? Because here I told you this for loop will go for n plus 1 means all the statements inside the for loop will go for n times, right? And here this for loop is going only for n times. So all the statements inside the for loop will be going for n minus 1 times, will be executing for n minus 1 times, right? Please try to understand this relation, right? Then what is the time complexity? Okay, so let's say this is my, again I'll go for a for loop. Okay, let me have only one print statement. Okay, so this is the program. I just want to print something, say apple 5 times. Okay, n times. I just want to print apple n times. That is the idea of this program, right? So I am asking what is the time complexity of this particular pseudocode, right? Or the algorithm. What is the time complexity, right? So how to analyze? This for loop will execute for upper index minus lower index plus 2. Okay, I think it's plus 1. Sorry, plus 1. All right. So upper index minus lower index plus 1. Yeah, it will be 2. It will be 2 uh, whenever there is less than or equal to n. Okay, whenever there is less than or equal to n, you will be having 2. Whenever there is less than n, you can go with 1. Okay, so the formula here is upper index minus lower index plus 1. Okay, right. Okay, super. So n minus 0 plus 1. So it will go n plus 1 times. And all the statements inside the loop will go for n times. So what total frequency count? You just add these two. So n plus n plus 1. So n plus n plus 1. And if you add this, you'll get 2n plus 1. Right? So that is the total frequency count. And if somebody asks me what is the big O of this particular total frequency count, 2n plus 1, that is O of n. To find big O, you just have to ignore all the constants and you have to take the n. So this particular set of code is taking, sorry, this particular set of code is taking on times, which means linear time. Okay, O of n time. Okay, and it is very crucial to remember that, guys, a single for loop will take only O of n times. Okay, will take O of n time, right? Linear time. A single for loop will always take a linear time, right? What if I have two for loops in my program? Let's say uh, my program is to get the array elements and print that, right? So I'll be having one for loop here. Okay, I'll write a proper algorithm, right? So void some function. Okay, here first I will be having a for loop, right? Which will go n times, right? And what it will get, it will get some elements, get a. Okay, so get some elements, and for I'll be having one more loop. Okay, it will print those elements. Okay, so this is simple algorithm, right? So in this case, what is the time complexity of this algorithm? If somebody asks you, then you have to tell that this particular algorithm's time complexity. Okay, wait. All right. This statement will take n plus 1 times. You know that, right? So n minus 0 plus 1, n plus 1 times. Everything inside that loop will take n times. This loop will take again n plus 1 times. Everything inside the loop will take n times. What is the total frequency count? You just have to add all these, right? Understand, these two are separate for loops. Okay, those are they are not nested. Okay, they are not nested. in the very next example, I will talk about a nested loop, but these two are not nested. Okay, they are separate. They are independent for loops. Okay, of course they depend on n, the size of the array, but they are independent to each other. Okay, that's what I'm insisting, right? So uh, total frequency count is you have to add all the numbers, right? So n, so you have 4n. So 4n plus 2. Okay, n, 2n, 3n, 4n, 4n plus 2, right? What is the big O? What is the big O? Big O is you have to ignore 4 and 2, so big O is O of n, right? That is the linear time complexity, right? So this program will take linear time. This program is taking linear time. Understand that even if you have 100 for loops, even if you have 100 for loops separately like this will take only linear time. All right, because if you are having lot of for loops separately, it will take only linear time, right? So that's the idea here. You can have a lot of for loops separately. Please note this point. Okay, in your program, you are allowed to have a lot of for loops separately, but if you are nesting it, that is a problem. I'll tell you the problem in the very next example, right? So again, a single independent for loop will take only a linear time. That is something to be remembered. Okay, often. Right. I'll go for one more example. Okay. Let's say I just want to get a two-dimensional array. So scan a two-dimensional array. Okay, this is one a classical example. Okay, scan a two-dimensional array. One of the classical example to explain nested for loops, right? Two-dimensional array, how do you represent it? Let's say my array is A, so you have to represent like this. A single element is represented like this, right? So void 2D for I equals to 0, I less than m is number of rows, okay? Rows in the two-dimensional array is nothing but the matrix, right? So m denotes the number of rows. One second. Yeah, so I plus. Okay, inside this for loop I should have one more for loop. Again, it is not independent. Inside this for loop I am having one more for loop, and it goes up to number of columns, right? It is row and it is number of columns. Inside this only I have to scan the elements. Okay, and again there is no need to write scanf here in this algorithm because we are studying algorithm, not C programming. Okay, we are implementing this algorithm using C programming, and that is different. But here we are writing algorithm, so there is no need to write scanf. Okay, okay, I think this way it goes. Okay, so here what's the time complexity, right? I'll close this first. Okay, so let me consider this as n also, so that it will be easy for you, right? I mean number of rows equals to number of columns, both are n. Okay, so this will go n plus 1 time, you know that, right? So this will go n plus 1 time, and everything inside the loop will go n times. So put n immediately. Everything inside the for this outer loop will go for n times. Okay, and again you are having one more loop here. Okay, which will again go for n plus 1 time. So into n plus 1, right? I hope you are understanding this. I hope that, right? So the outer loop will be going for n plus 1 times, will execute for n plus 1 times. So all the statements inside the outer loop will also execute for n plus 1 times. I think this one comes here. Let me put this here, right? Right. So everything inside the for loop will be executing for n times, right? And again this inner loop will be executing for n plus 1 time. So always put into n plus 1. Okay, this inner loop will be executing for n plus 1 times, and everything inside the loop will be executing for n times. So put n here. Okay, so that's how it goes. N plus 1 n again n plus 1 n. That's it. So that's how it goes. Okay, so Yeah, this is n plus 1 times everything inside the loop n times. So again the inner loop will go for n plus 1 times, so that is getting multiplied, and inner you are having another statement and that will go for n times. So understand that this n is because of outer loop, that is I, which has I, and this n is because of inner loop, which is j, right? And what is the time complexity in this case? Let's first find the total frequency count, and after that we will go for time complexity, right? So let me write these statements again, right? So first statement is n plus 1 times, superb. Second statement is n into n plus 1, you can see that here, n into n plus 1, so n into n plus 1, which will be nothing but n square plus n, all right? And third statement is n into n, which is nothing but n square. So I am adding up. I am adding up all these. What I'll get here is I'll get 2n square plus 2n plus 1. Okay, plus 1. All right. Super. So this is the total frequency count. 2n square plus 2n plus 1. Right. And so what's the big O here? What is big O? Big O is nothing but you have to ignore all the constants. Again, you are having n square and n, but you have to take only the worst case, that is n square, the n square, right? So the big O for this algorithm is time complexity is O n square. That is the worst case time complexity. That's the maximum time complexity. This is quadratic time complexity or polynomial time complexity, right? Yeah, which is worse, right? So understand that if you are having nested for loops, you will definitely have, or you are supposed to have this n square time complexity. So it is it is best to avoid those for loops unless you don't have any other way to go, right? And what if I have three loops like this, right? What if I have three loops? What is the time complexity? If somebody asks me, I could easily say that is O n q, okay? A cubic time complexity, which is even more worse, right? If I have three loops which are nested, okay, which are nested. But if what if I have separately, okay, separately I have three loops which are not nested, independent loops, then irrespective of the number of loops I have, I will be having only linear time complexity, right? And that is something to be understood here. Okay, I hope it is clear to you. Right. Let me see a few example. Okay, let me show you few example for logarithmic time complexity. Okay, because that's something I have not touched. Right. I hope you have understood these concepts. So logarithmic time. Let me show you some examples. Logarithmic time complexity. Okay, let me go with the for loop itself. I less than n, I equals to I multiplied with 2, and inside which I have some statements. Okay, and here can you note any difference between the for loops which I have written before and the current for loop? Yes, definitely. That is the increment type, right? I am just multiplying. Okay, I am just multiplying. Okay, which will reach the end value even more faster than the increment. uh, Instead of going for I plus plus, I am writing I equals to I into 2, which will reach the n value even more faster, right? Because it's getting multiplied. Say my n is 5, okay. So my first iteration I will be 0, second iteration I will be okay, I should start from 1, right? I should definitely start from 1 because I'm multiplying. So if I start from 0, then 0 multiplied any number is again 0. So this loop will not end at all, right? So I'll start from 1. Okay, I should not start from 0. I should start from 1 here. I'm starting from 1, right? And after that, I'll be multiplying that with 2, so I'll get 2. After that, if I multiply that with 2, I'll get 4, right? If I multiply that with 2, that I'll get 8, but my for loop ends here itself. My for loop ends 4 itself. So my for loop will execute only for 3 times, not for 5 times. It will execute only for 3 times, 1, 2 and 4, because it is getting multiplied. I is getting multiplied. Okay, that is the concept I wish to emphasize here. I is getting multiplied by a number 2. All right. So keeping that in mind, let's try to analyze this algorithm, right? This for loop actually. This is not a complete algorithm, right? Erase all this stuff. Yeah, that is something important to be understood, multiplying, so that let it be there. And change it to 1. Yeah, so I equals to I into 2. Superb, right? Okay, so my n value is somewhere, I don't know what is my n value, let's say. Then my I will execute 1 times, my I will execute 2 times, my I will become 4, my I will again become 8, my I will become 16, my I will become 32, and again my I will become 64. And because that's how it is getting incremented, you can see that here I into 2 only. So in each for each iteration it's getting multiplied by 2 until the n value is reached. I don't know where is my n value. So until the n value is reached, it is getting multiplied by 2, right? If this is the case, if that is the case, then you can write 1 as 2 power, uh, sorry, can write 1 as 2 power 0. You can write 2 as 2 power 1. It is 2 power 2. It is 2 power 3. 2 power 4. 2 raised 5. 2 raised 6. And let's say this execute up to n times, right? And this n is something which is 2 power k, right? 2 power k times. Okay, what is k? K is the number of times the algorithm executes. Okay, I don't know what is k. K is number of times that the for loop executes. Okay, number of times the for loop executes. Okay, so that is k. Okay, so how it is number of time, because you can see 0th time I is 1, first time I becomes 2, second iteration I becomes 4, third iteration I becomes 8, right? So k is nothing but the number of iterations or number of times, or if that both are correct, right? So it will always be in terms of 2 power k. Okay, so 2 power some value, that's the number of iteration. So at most n can go up to 2 power k only. That's the idea here. The number of times, the total time can go up to only 2 power k, right? So number of iteration, right? So 2 power k equals to n. Okay, n is nothing but number of the input size. Okay, okay, fine. 2 power k. Now let's apply logarithm on both sides. Why? Because I have some constant term in power, right? So definitely I have to apply logarithm on both sides. What I'll get, I'll apply log 2, guys. I'll assume the base of the log is 2. So what I'll get is log 2, 2 power k here. Here I'll get log 2n, right? And here there is a property for log. I'll take the power inside. I can always take the exponent before the logarithmic, right? So there's a power like this, and there's a rule like this. Log x power y can be written as y into log x. Okay, applying this particular theorem, I would get k log base to 2 equals to log base to n, right? And this will be 1, right? Always when the base and the decimal is same, you can always cancel that and become 1. So log of same base and exponent will always become 1. Okay, so applying that, what I will be ending up here is k equals to log 2n, right? And k is the number of times the program execute. So this is the total frequency count, number of times the program executes, right? I told you number of times the program executes or number of iterations. That is exactly the total frequency count, right? Hooray, right? So total frequency count, here it is log base to n, or you can say that is log n, right? So the big O is definitely log n for this particular algorithm, right? For this particular for loop, the big O is definitely log of n. You can see that how it become log of n. Whenever you have it's getting multiplied by 2, the big O is definitely log n, right? That's how it goes. Okay, so that's the example of logarithmic time complexity, guys. I think these are the fundamentals that you should remember. Again, in the next video, we'll see some examples to find the time complexities. Please do watch the next video because that's very important. That's something very important. Uh, if you watch the next video, it will be very easy for you to attend some competitive exams where they will ask a lot of time complexities like this, right? Thanks a lot, guys.